Okay, we are recording. Good morning, everybody. So I'm doing a recorded lecture for Chapter 6 in our intermediate accounting textbook. That is the next chapter that we're going over and that we're starting on Monday. And so Chapter 6, and we'll see examples in the PowerPoints, of course, and get some practice with it together. But Chapter 6 is really focused on the time value of money. So the basic principle behind the time value of money is that a dollar today is worth more than a dollar promised in the future. Because if we have it today, we can invest it and we can earn money and it'd be worth more than a dollar in the future, right? So that's kind of the basic principle behind the time value of money. A dollar today is worth more than a dollar promised in the future. Again, we can invest it, we can earn more money off of it, we could turn it into more than a dollar if we have it, right? So a dollar today is worth more than a dollar in the future. So we look at in this chapter present value, future value calculations for a single sum of money. We look at present value, future value calculations for multiple cash flows, which are called annuities. And then we look at how some of our accounts are valued using this or these present value, future value formulas and calculations. Like, for example, bonds payable. So bonds payable, which we talk a lot more about in chapter 14. And I know I looked up the chapter before I said it, so I can make sure I could tell you guys what chapter, but we go a lot more into bonds payable in chapter 14. But one of the ways that we look at or use these present value, future value calculations is for bonds payable and determining how much we would sell the bond for. So, how much we sell the bond for is a function of the present value of the lump sum, the face value of the bond. So we discount that back. We determine the present value of the face value of the bond, right? And then we discount back and we determine the present value of the interest payments, which is a present value of annuity calculation. So we take the present value of the lump sum and we take the present value of the annuities, discount those back, right? Take away the interest to determine how much we would sell that bond for. So, again, we use these types of calculations I mentioned in class, like especially the future value of annuity formula that we'll look at and get practice with. We use that for retirement calculations to determine how much money we could have in 40 years, for example. So, I really like this chapter. I'm excited to do some of these formulas together. But anyway, I will share my screen with you and we will go through this together. Okay, so chapter 6, again, like it shows here, time value of money and our learning objectives. So the fundamental concepts related to the time value of money, we just kind of touched on that. Remember, a dollar today is worth more than a dollar promised in the future. Solve future present value of one. So those are single cash flows. Solve future value of ordinary and annuity due. Solve present value of ordinary and annuity due problems, and then solve present value problems related to deferred annuities, bonds, and expected cash flows. So that's what we're looking at in this chapter. Okay, so I mentioned this a moment ago, the time value of money, the relationship between time and money. A dollar today is worth more than a dollar promised in the future. And so, again, what we're going to be looking at is present value, future value calculations. And so present value calculations, we know what we want it to be worth in the future. We're going to discount back and calculate the present value to determine what we need to save today. So, for example, if we wanted to go on a vacation a year from now and we want to save $1,000. We'd say, okay, how much do we need to put in the bank today? Let it grow some interest and it'll be 1,000 in a year, right? So we know we want it to be 1,000 in a year. We're going to discount back and take away the interest to determine what we would need today, right? So present value of one. The future value calculation is we know what we have now. If we put it in the bank and it earns X amount of interest, how much will it be worth in the future? Or if we put it in some investment, it doesn't have to be put it in the bank. It could be some investment, right? So if we have $1,000 today, we put it in the bank or put it in, we put it into some investment, growing at X amount of interest, how much is it going to be worth in the future type deal, right? So that's what we're looking at, time value of money. So some of the different things that we use the time value of money to calculate, and again, we talk about these different things as we continue through the textbook. I did not necessarily look up every single chapter to tell you what chapter we're looking at these things in, but I did look up bonds, and I know we talk more about bonds, which are long-term liabilities, right? So we talk more about bonds, chapter 14. Notes, same thing. Notes are considered usually a long-term liability. So that's what we're talking about in chapter 14. Also, leases are valued this way, pensions and some retirement benefits, some long-term assets. We talked about some of our financial or equity or debt security investment instruments or financial instruments. Some of these we value at fair value or present value, right? Shared-based compensation, business combinations, disclosures, environmental liabilities. Again, these things, some of them, if we know, like for example, with an environmental liability, if we know that this environmental liability is going to be, say $1 million in 2 years, then we can discount back, we can determine, what is it presently if we take away the interest, how much do we need to have now to cover that liability coming up type thing, right? So that's kind of what we're looking at in this chapter. All right, so interest, interest, and it can be simple interest or it can be compound interest. But essentially the interest is what we earn off of our investment. So the excess cash received or repaid over the amount lent or borrowed. And so, again, just using a simple example, if we invest $1,000 and it earns $100 in interest, then that investment, $1,100, right? So we invest $1,000, say over a year, and at the end of the year, it's worth $1,100. Then that's our $1,000 principal, plus the $100 in interest it earned, right? So interest, if we're investing money, we earn interest. If we're borrowing money, we have to pay interest, right? So car loans, home loans, credit cards, all of those things, we have to pay interest when using those things. So car loan, you have interest, usually, and it depends. The better credit that you have, the less interest that you have to pay. But let's say you have a car loan and it's, 4% interest, 5% interest you pay on it. And then your home loan is even less than that. Mortgages, normal mortgage is a 30-year mortgage. So then you're looking at, 3% interest, 3.5% interest, around there somewhere. And then you're looking at some of these credit cards, even Visa, MasterCard, some of the bigger ones, you're looking at 15, 20% interest. And then when you talk about credit cards like Home Depot, for example, or Lowe's, or Dillard's, or Macy's, or, these store accounts, you're talking about interest 25, 26%. So, if we're borrowing money or we're using money from another company for something, whether it's to buy a house, a car, or clothes at Macy's or whatever, right? If we're using the money, then we have to pay interest on it, right? If we invest money, so we take our money, we invest in something, then we earn interest off of it. So some of the vocabulary here: principal, the amount borrowed or invested; interest rate, the percentage of the outstanding principal; time, the number of years or fractional portion of a year that the principal is outstanding. Okay, so variables that we're going to be looking at calculating, and of course some of these are going to be given, and then we'll have to calculate one of them. For example, they'll give us 3 and then we have to calculate one of them. So present value, again, what an investment or what an amount of money is worth now, right? Potential interest rate, that's the amount of interest that we're going to earn off the investment, whether it's 6%, 8%, 10%, right? The interest rate. Future value, what it's worth in the future at a future period, whether that's 2 years from now in the future, or 5 years or 10 years in the future, right? In the future, a year, right? In the future. And then the number of periods. So this is usually the number of years, but sometimes periods can be, we could have 2 periods a year. We could have 4 periods a year. We'll talk about that a little bit more as we go through. But this example is showing us years, so, or at least 5 periods, right? So if we were looking at this like years, year 1, year 2, year 3, year 4, year 5, right? So 5-year period. All right, so here's our simple interest example. And so I mentioned simple interest versus compound interest. Simple interest, just like it shows here, is the interest that's computed on the principal only. So in this example, it's a $10,000 principal. So the interest is only being calculated based on that $10,000 principal, whereas compound interest, which I think it touches on in a couple slides if I'm remembering correctly, but compound interest is where even our interest can earn interest. So then interest is computed not on the principal only, but the principal plus interest type thing. So anyway, this is a simple interest example. So Barstow Electric Inc. borrows $10,000 for 3 years at a simple interest rate of 8% per year. Compute the total interest to be paid. So that formula for interest, and I'll write this on the board when we're working on these, but principal times interest times the number of periods are what those variables stand for, right? So principal is the P, interest is the I, and then N is the number of periods. So if it's a 1 year, then we take 10,000 times 0.08, right? 8% interest times 1 year, right? So $800 in interest after 1 year, 8% of 10,000. Okay, so then after 1 year, Barstow Electric would owe $10,800, right? Not only the 10,000 principal that they borrowed, but then this interest that it's incurred as well, right? So 10,800 is what they'd owe after 1 year. Okay. So 3 years, then we're taking 10,000 times 0.08 times 3, 3 years, right? So 2,400. And then partial year. So the partial year example, 3/12. So this would be if we were calculating interest for 3 months. So for a quarter, basically, 3 out of 12 months. And some Investments do pay quarterly. Like, for example, some companies that pay dividends pay their dividends every quarter. Bond, so then that would be 4 periods per year, right? If they pay dividends to stockholders every quarter, then they're paying dividends 4 times a year, probably like I don't know, December 31, um, maybe March 31, June 30th, and September 30th, right? Like the end of every quarter, basically, if we were on a calendar year. But and then bondholders, and then again, we're going to talk about this more with but bondholders are usually paid interest semi-annually or twice a year. So then that's 2 periods a year if we're thinking about this formula. Okay, and so then we take 10,000 times 0.08. Again, we know that's 800, but then times 25% or 3/12. So only $200 is what interest it would have incurred. Okay. Compound interest, again, we just touched on this a moment ago, and hot dog. And, we said with compound interest, interest is incurred or gained on the interest as well. So when we're calculating interest, we're not just looking at that principal amount, we're looking at the principal plus interest. So that's what it shows here, right? Computes interest on principal and the interest earned that has not been paid or withdrawn. In the case of if we take out a loan, it's the interest earned that has not been paid. In the case that we are making an investment and we are earning interest that way, it's the interest that has not been withdrawn, right? So this is where with compound interest that we get into the annuity and multiple cash flows. All right, so here's our example of that. It says, and I do not know how to pronounce this, Tomalizik company deposits $10,000 in the Last National Bank, where it will earn simple interest of 9% per year. It deposits another $10,000 in the First State Bank, where it will earn compound interest of 9% per year, compounded annually. In both cases, Tomalizik will not withdraw any interest until 3 years from the date of the deposit. Okay, so then what's it going to be worth based on the different banks, right? Last National Bank, where it's simple interest, it's going to be worth $2,700, right? Taking that $10,000 times 9 is going to get $900 a year. So then $2,700 is the interest on that loan, right? The interest that he will earn, because in this example, where the last example, the person was taking out a $10,000 loan. In this example, this person is depositing $10,000 into the bank, right? So it's earning interest, $2,700 in this case, where if we go to First State Bank and the interest is compounded, what's going to happen is after the first year, so after the first year, $10,900, right? So 10,000 times the 9%, 900. At the end of the year, it's $10,900. With compound interest, the whole 10,900 is now earning 9% interest. So then year 2 down here, we would be at 10,900 times 9%. That would calculate to whatever it is. And I don't know why it's not. Oh, here we go. I guess I just I just had to click on it. I'm like, I don't know why it's not showing up. So yeah, so you see it here better now. So first year, 10,000 times 9%, $900 interest. So now it's worth 10,900. So then year 2, we're taking 10,900 times 9%. Now that earns us $981 in interest. So now it's worth $11,881. So then year 3, $11,881 is compounding interest. So then we earn $1,069. So we can see here that there is a difference in simple interest versus compound interest, because again, with compound interest, simply put, our interest is earning interest, right? And so that's what we want. And especially for retirement savings, and when we get into individual IRAs, individual retirement accounts, that's what we want, is that compound interest. Okay, so we mentioned this earlier when we kind of were looking at this diagram or this illustration out of your book. Sometimes we'll do calculations where we have an unknown present value. In that case, if it's unknown present value, they have to give us future value. If it's unknown present, they have to give us future so that we can calculate present, right? But sometimes then we'll have calculations where we know the present value, but it's unknown future value. So we're calculating future value. Again, if they're asking us to calculate future value, they have to give us present value, right? So they have to give us one of those things. And then also the interest rate and the number of periods. And as we'll see as we go through the rest of the chapter and some of these exercises together, sometimes we don't know the interest rate. We got to calculate that. Or sometimes we want to know what number of periods. How long do we need to keep the investment for example, the number of periods. We won't know. We'll have to calculate. So there's some different things that we can calculate from here as well. All right, so here's our future value example. And then again, this is of a single sum. So, we deposit X amount today. How much is it worth at some point in the future, right? Just a single sum of money, where annuities, when we start talking about these will be like, okay, if we deposit, $1,000 every year for 10 years, right? So multiple cash flows. But anyway, here's our example of the single sum. So, Bruger Company wants to determine the future value of $50,000 invested for 5 years, compounded annually at an interest rate of 6%. So we see our formula up here. So future value in some number of periods is what that means, equals present value times 1 plus the interest rate to the number of years, right? So if we're thinking about this $50,000 invested for 5 years, rate of 6%, then we'd end up with present value 50,000 times 1 plus 0.06, as we're seeing down here, right? 1 plus 0.06 to the number of years. And so if we simplify this, we end up with a factor 1.33823. And these factors right here, and it's called the future value factor. This factor right here, these are listed, and we have tables that these come from. But future value of 1, this is on table or on page 314 and 315 of your textbook. So, and there's several tables. There's a future value of 1, there's present value of 1, there is future value of ordinary annuity, present value of ordinary annuity, present value of annuity due. So there's several different tables. They go from page 314 to 323 in your textbook. And so we're going to get practice with it both ways together. We're going to get practice plugging the numbers in. And we're also going to get practice looking up this factor in the tables. So we'll get practice with it both ways together. So if we take that 50,000 again for 5 years at 6% interest, then at the end of 5 years, when this investment matures, be worth $66,912. Okay. All right, present value of single sum. Again, with this one, we knew the present value. The present value was the 50,000, right? We knew the present value. We want to calculate the future value. And so now in this example, we know what we want the future value to be, we're going to calculate it back and determine, or we know what the future value is. We're going to calculate it back and determine the present value. So we're going to take away the interest. Again, with this example, future value, we were adding interest, 5 years worth of compound interest, right? We were adding to it. With present value, we're taking it away. So that's called discounting. We're discounting it back. We're taking away the interest and getting it to its present value. I need something to drink. Excuse me. Okay. And so we see on this one, again, present value equals future value divided by 1 plus the interest to the number of years, right? This is 5 years. So what is the present value of $73,466 to be received or paid in 5 years, discounted at 8% compounded annually? So this is the future value in 5 years. In 5 years, it'll be worth $73,466, which is a very random number. But anyway, 5 years, and it's 8% interest. So we're going to take away the 8% interest, basically, right, for what it would have compounded for 5 years. So we see the numbers plugged in here. So 73466, and then 1 divided by 1 plus the interest rate to the number of years, the factor that gives us, and this is the factor that we would see on the present value tables. So that would equal 50,000 if we take away that interest. All right, again, I mentioned this earlier. We can compute other unknown variables like the number of periods or the interest rate if we don't know that. So here's a couple examples of that. It says the village of Somonauk wants to accumulate 70,000 for the construction of a veterans monument in the town square. At the beginning of the current year, the village deposits $47,811 in a memorial fund that earns 10% interest compounded annually. How many years will it take to accumulate 70,000 in the memorial fund? So we don't know the number of years. We know what it's worth now. We know the present value. We know the interest we're going to earn. We know what we want it to be worth, future value. So then we can take that and calculate the number of periods. And so we see here, my goodness. And so we see here, we take that 70,000 divided by 47,811. That's going to give us that factor. And that's the factor that we want to find on our table. And so it shows us here, and these tables, again, are listed in your book. If we go at our interest rate, 10% per year, how many periods do we go down before we hit that factor, before we're at that factor? And so we'll see in this case, 4 periods or 4 years is what we're doing the calculation for. And this is the same way really that we solve for an unknown interest rate. We find it on the table. So, okay, solving for other unknowns. Again, this one now we're looking at unknown interest rate. So Advanced Design Inc. needs $1,070,584 for basic research 5 years from now. The company currently has $800,000 to invest for that purpose. At what interest must it invest the $800,000 to fund basic research projects of $1,070,584 5 years from now? So again, present value $800,000, future value $1,070,584. 5 years is what we're looking at for the number of periods, and we want to know what the interest rate is. So again, we take that future value divided by present value. So $1,070,584 divided by 800,000, and we get this factor. And again, we find that factor on the table. And so if we're this time looking at 5 periods, and then we continue over the or down the 5 period row, then we see we hit that factor at 6%. So not too bad. Okay, future value of ordinary annuity. So this is kind of the formula that we look at, looking at some of our retirement calculations. So in this case, it's multiple cash flows. So on this one, we're showing, so we're investing, it looks like $20,000 a year. So, you know, here we're starting at 0, then we invest 20,000. We invest 20,000, we invest 20,000, we invest another 20,000, we invest another 20,000, we invest another 20,000, we invest another 20,000, right? So it's multiple cash flows. We're investing X amount per year, every year for a number of years, right? So here's our example of that. And you see this formula here. Again, I'll put this on the board when we get practice with these in class together. But payment times the number, or payment times 1 plus the interest rate to the number of years minus 1, all divided by the interest rate. And so what is the future value of $5,000 deposits made at the end of each year for the next 5 years, earning interest of 6%. So we see the numbers plugged in here, right? So 1 plus the interest rate to the number of years minus 1, all divided by that interest rate. Although I just noticed on this slide, it should be 0.06 like it is up here. 0.6, that would be 60% interest. That stood out to me. I just noticed this error on the book slide. Anyway, so then we're taking the 5,000 times that factor that we've calculated inside the parentheses. And so that tells us that this would be worth $28,185 in 5 years. And so you know, essentially we're depositing 25,000, right? Because we're putting in $5,000 every year for 5 years. So we're putting in 25,000, but it's going to earn the difference, what, $3,185 in interest. Okay, present value of ordinary annuity. You know, again, with present value calculations, we're going to discount back and we're going to take away the interest of a series of equal payments, so multiple cash flows. So here's our example of that. It says, what is the present value of rental receipts of $6,000 each to be received at the end of each of the next 5 years when discounted at 6%. Okay, so if we're going to receive rental receipts of $6,000 each for 5 years, then once we get all 5 payments in, that would be worth $30,000, right? 6,000 times 5, right? So once we got all 6,000 of these in over the 5 years, that would be $30,000, right? But we're going to discount back. We're going to take away the interest. And so in this case, that formula, again, the payment amount times, and you see here the formula gets a little bit more complicated. So 1 minus 1 divided by 1 plus the interest rate to the number of years, and then that divided by interest rate. So you really do have to solve what's in the brackets and parentheses first, right? Or I should say what's in the parentheses and brackets first. But anyway, so we plug our numbers in here. We come up with a factor there that we would have calculated up in the brackets, and that we can find on the factors, the tables. And so that would be worth 25,207. Hot dog. $25,274.16, discounting that interest back. So anyway, we'll get practice with some of those calculations and looking it up on the tables together. Okay, so some other time value of money issues that we have to look at. Deferred annuities. So, you know, this is where, you know, maybe we invest the money today, but it's not going to start paying us until 5 years from now or something like that, right? And so what we have to do then, we have to, you know, take the whole period and then subtract the periods that are deferred, basically is what we look at doing in these deferred annuity calculations. So with the, and this is what we think about with the bonds. And I mentioned this earlier when we started the PowerPoint, is that when we're thinking about determining the present value of long-term bonds, and how would we sell, you know, say we want to issue 5-year bonds. We know what we're going to have to pay in the future. We can discount it back. We can determine what it's worth presently. That's how much then we can sell it for presently. So we do that by calculating the present value of the periodic interest payments. Remember, I mentioned that bonds are usually paid semi-annually, so 2 periods a year. If it's a 5-year bond, we're going to use our formulas and calculate it based on 10 periods. Or if it's a 10-year bond, 20 periods, because it's bonds are paid semi-annually every 6 months, 2 periods a year. So we're going to calculate the present value of the interest payments, and then we're going to calculate the present value of the principal amount, or the face value of the bond is the principal amount, to determine what it's worth presently. So here's our example of that. It says Alltech Corporation on January 1, 2017 issues 100,000 of 5% bonds due in 5 years with interest payable annually at year end. The current market rate of interest for bonds of similar risk is 6%. What will the buyers pay for this bond issue? So again, we want to calculate the present value of the interest payments, the present value of the lump sum amount. So for the interest payments, so this is a $5,000 interest payment, and then I forgot, what is this? This is a 5-year bond, and this interest on this bond is payable annually, so that's okay. We're going to use 5 years then, or 5 periods. So then we'll see that interest payment is 5,000, right? 100,000 times our 5%, right? 100,000 times 5%. So then that's $5,000 interest. And again, we're trying to calculate the present value of these interest payments. So we're looking at the present value of ordinary annuity table. This particular table is on the present value of ordinary annuity, page 320, page 321 of your textbook. But if it's, you know, again, 5 periods, it's a 5-year bond that pays interest only annually, so 5 periods. And then we look at that 6% column, we'll see that factor. So we take our 5,000 times that factor, and the present value of those interest payment, 21,061.8. So, you know, again, $5,000 a year for 5 years, that would be 25,000 that these bondholders would be paid if they waited the entire 5 years, right? 25,000, 5,000 a year for 5 years, they'd be paid 25,000. But when we take away that interest and discount it back to what it's worth presently, it's presently worth 21,061.8, right? So we calculated the present value of the interest. Now we're going to look at calculating the present value of the lump sum, the 100,000 in bonds, right? Because at the end of 5 years, the company has to pay back those bondholders 100,000, that lump sum, that face value of the bond. So then we look at, for this one, the present value of one table, because that's a lump sum. That's not like the periodic interest payments. This one's a lump sum. So then we're looking at present value of one table. Present value of one table is on page 316, 317 of your textbook. And so we look at that number of periods, and then we match it to the interest rate, 6%. And so we get a factor of 0.74726. So we're taking that $100,000 principal times that factor. And that tells us, again, what it's worth now, $74,726. So 5-year bonds, if these bondholders held the bonds for 5 years, the company would pay back the bondholders $100,000. That's right, what it's at maturity, the value of these bonds at maturity, right? But if we discount back, we take away the interest, currently worth $74,726. Okay, so here's our example, you know, again, that we've looked at. We looked at calculating the present value of the interest. We looked at calculating the present value of the principal amount, or the face value of the bond. And so we would sell this bond, or these bonds, for $95,787, the combination of both the present value of the interest, the present value of the principal. And the way that we would record this, and again, we get more into this in chapter 14, but we would debit cash for the amount of cash being brought in. We would debit the discount on bonds payable for the difference between what we're selling them for and the face value at maturity, the face value of the bonds. So that's the discount on bonds payable. And then we credit bonds payable. And what's going to end up happening with this discount is we get to amortize this discount and add it to our interest expense as we are as we go through the years on this 5-year bond. We do get to, so we give a discount off the top, but we do get to claim this as interest expense throughout the life of the bond. So anyway, that gives us an example. All right, and then here's what I mean by amortization, or we get to amortize that bond discount. So remember that bond discount, $4,212.20. So we're selling these bonds for $95,787. But you know, in 5 years, we got to pay back $100,000 to the bondholders, plus the interest that we pay them every year, right? But this discount we get to amortize, we get to add it to the interest expense of the bond. So then we see what we mean by that. So here's what we start with: a carrying value. This is the amount of cash brought in from the bonds, or the carrying value of the bonds, right? And then at the end of the year, we pay bondholders $5,000 interest, cash. That's the cash interest paid. But we get to also claim some of that discount. And so the way that we look at that discount is we look at, okay, the total amount of the discount plus the actual cash expense that we're paying. So then you see over the year, over the course of the 5 years rather, that we're going to get to claim that discount as interest expense as well. So again, we're going to get practice calculating this together, and doing some of these amortization schedules together. Okay, so these are the exercises, at least that I had picked out from last school year when we taught this class, or when I taught this class last fall semester. So I'm going to take a closer look at the exercises, and we'll see which ones that we'll do. I don't know. I think that some of these are your homework exercises. So I certainly don't want to do all of your homework exercises, although I'll pick out a few and we will get practice with this starting on Monday. All right. Bye, guys. Have a good rest of your weekend.